Hello there. This time I want to show a bit of a topology building trick. So I have this piece A and piece B that I want to use for for creating this sort of clean final topology. A and B has same amount of points. Oh, not same amount of points, but part that should generate new topology have same amount of points. I have loft out 128 points, and on B I have loft in 128 points. So how do you create this sort of topology? Well, we could think something like PolyLoft would do. Because we have points, we're creating connection. Okay, let's see. Loft in, loft out, and yeah, that's not what we needed. What else could we try? We could try PolyBridge. This we need group promote and in out picking your groups in out and from point to edges, from point to edges. Okay, and it also doesn't work. Well, before showing you why, I'll show you, before showing how to do it, I'll show you why it doesn't work. Specifically, it doesn't work in both cases because both those nodes work on point ID. And point ID in this case is not matching in those groups. So it connects them somehow. So how to actually make it work? Now to actual solution. And for actual solution, I'm using Ray node. And Ray node needs. By the way, why one of the reasons why Ray node and not using sort in this previous approach, because it's a radial shape. You can easily sort it from left to right or from top to bottom. It's like you can create some difficult sorting algorithm, but that would be like an overkill. So for this Ray approach, for Ray to work properly, we need proper normals that would be pointing out from outside to inside. And normally you can just subtract 0 from P attribute, position attribute, and you would get what you need. But in this case, it would not work because it's not in 0 coordinates. And you could try to play around with match size, with saving X form, but that's just like we can do it right here without this trickery. And for doing it right here, all we need to do is to use get BBox center. That's it. We're taking our group, we're calculating bounding center of its bounding box, and we subtracting position from it. That's it. And it gives us perfect normals. Exactly what we need for A. But to keep proper topology and not just transfer top edges, I use polyextrude with those normals we created, and then just doing it again with creating proper normals for our group. Then ray, and normal node just to make it look fine. That's it. This, I suppose, quite a simple trick for creating this topology. So thank you for your attention.